welcome to Teaching a Monster How to Code. I'm Kat.
And I'm Waz.
And in today's installment, we're going to continue talking about codes and introduce the 4 principles of computational thinking.
I thought principles belong in school.
Wrong kind of principle, Waz. Computational thinking is thinking like a computer, or reducing a problem in a general way so that a computer can solve it. The 4 principles of computational thinking are decomposition, pattern recognition, abstraction, and algorithms. And before you even ask, don't worry, Waz. We're going to cover them in a really basic way, and we're going to use Lego to demonstrate.
Oh, phew.
First, decomposition. We have a big bin of Lego here, and if we are going to decompose this box, we would need to take apart or break down all of the pieces to single units. In other words, Lego pieces attached to no other Lego pieces.
Okay, but what do we do with them? Does it matter if the square pieces go with the rectangular pieces?
Good, Waz. You're already thinking into the next step, which is pattern recognition. We're going to sort all of the pieces by size or color or both and go from a big bin down to individual containers. So maybe we sort by shade, so different colors of green are all mixed together. We sort by pure colors, so blue or red are separated but not worrying about size. Or we separate by size and color, so the white 2x4s, 2x3s, and 2x4s are all separated.
Cool.
Next, we're going to go on to abstraction, which is a little tricky, so we're going to use this Lego house to think about it. Waz, if you were going to build a Lego house, what are the most important parts of a house that need to be included so that anyone would know that it's a house?
Well, it needs 4 walls, windows, a roof, and a door.
Close, but have you ever seen a house that has more than 4 walls?
Oh, I think I have.
Good, so does every house only have 4 walls?
I guess not. But all houses should have walls, right?
Exactly.
Ah.
This is an example of abstraction, where we reduce something down to its generic characteristics, or a model in computational thinking. A house usually has walls, a roof, some doors, and some windows. Some houses have more, some houses have less, and some houses can be different colors. But all of these things should be ignored when we build our model of a house with abstraction.
That makes sense.
Lastly, we create an algorithm, which is the execution of the model. For our Lego example, that means building the house that we made a model of. In general, an algorithm is the step-by-step process that follows the model you created.
That kind of makes sense. I mean, I get the Lego examples in concept, sort of.
We could apply this to anything you might want to build with Lego, but let's explore further with our screen-free coding activity, which brings us back to codes. Here we have a string of Lego pieces, which is a substitution cipher, which we learned all about last week, and it represents a word. The key shows that every 5 pieces of Lego represents 1 letter, and each letter is a different combination of 2 colors of Lego pieces. For us, yellow and red.
Well, Codebreaker Waz is ready to tackle that code. Now, can I start with the key this time?
Yes, you can. The key is here, and here is the code. Get to it.
Thank you.
You would start with decomposition, reducing the code to its base parts. For our code, that's each 5 pieces of Lego. Then you use the key to identify the pattern of the Lego and what letter it represents. Use abstraction to ignore any features that are unimportant. For Waz, that's these Lego pieces that have eyes on them. Then you put it all together with an algorithm, swapping letters for Lego pieces to crack the code, which is Waz?
Candy!
Good job! Here you go.
Thank you.
We put this mini code together for you to crack at home using the key that we've included in the description below. You can make and send as many codes as you want with it, or you can use the blank key we've included to create your own Lego key code. We hope you have a lot of fun, and we'll see you next time. Bye!
Bye!